All right, guys, if you would grab out your Shape Up Unit Assessment Review, and we're going to go and walk through each individual portion of it. So if you'll take a look at the very top, it's giving us circle, and it's giving us a couple of pieces of information that are very important. Circumference of a circle, we use two different formulas, C equals pi d, where we use this formula if we are given the diameter of the circle. Or if we have C equals 2 pi r, this formula is helpful if we are given the radius of our circle. For the area of a circle, we only have one formula, A equals pi r squared, which we can separate this out into area is equal to pi times r, because r squared is just r times r, not r times 2. So we're going to fill in a blank, and it says the distance around the circle is known as the circumference. Let's see, spelling E-R-E-N-C-E. The distance from the center of the circle to the edge. So if we draw ourselves a little picture from the center to the edge, this is known as the radius. The distance from one side of the circle to the other side of the circle. So if I draw a picture, I've got from here through here, and do not forget, it must go through the center point. Sorry, this right here is known as the diameter. The diameter is blank the length of the radius. Well, the diameter is twice the length of the radius, whereas the radius is half the length of the diameter. Sorry. There we go. Half the length of the diameter. Pi is known as the ratio of circumference to diameter. So pi is known as C over D. All right, so Elizabeth bought a circular rug with a diameter of 8 feet. What is the circumference of the rug? Round your answer to the nearest hundredths place. Well, we learned up here that we've got two different formulas for circumference. Well, I'm given the diameter, so I'm going to use pi d. So first step, write my formula. C equals pi d. I'm given the diameter, so I already know that. I'm going to change pi into 3.14 times the diameter of 8, which is step 2 is to plug in. And step 3 is to solve. All right, 3.14 times 8. 8 times 4 is 32. 8 times 1 is 8, plus 3 more, 9, 10, 11. 8 times 3 is 24, plus 1 more is 25. Do not forget the placeholder or the decimal places. I've got 2 here, 0 here, so I'm going to move it 2 times to give me C is equal to 25.12 feet. 25.12 feet. All right, number 3. Hannah is painting a circular board for her room. The diameter of the board is 10 centimeters. She wants to determine how much paint she should purchase. She is solving for the area, or is she solving for area or circumference? Well, if this is the circular board and we're wanting to paint the entire thing, I am looking for the area of my picture. So I need to calculate the amount of paint that she will need and round the answer to the nearest hundredths place. Well, we're told that area is equal to pi r squared. Well, the first issue I have is that I'm given 10, and I'm given that 10 is known as my diameter. So to find the radius of my diameter, I have to take my diameter and divide it by 2, and that's going to give me a radius of 5. Now I can plug in my information and solve. So area is equal to 3.14 times 5 times 5. I can go ahead and combine 5 times 5. That one's easy, as 25. And then we're going to come over here, 3.14 times 25. 5 times 4 is 20, carry the 2. 5 times 1 is 5, plus 2 more is 7. 5 times 3 is 15. Done with the 5, placeholder. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. Now that I'm finished, I need to add everything up. 0 plus 0 is 0. 7 plus 8 is 15. 5 plus 2 is 7, plus 1 more is 8. 6 plus 1 is 7. I have 2 place values here. I have none here. So this decimal place needs to move 2 times to give me my area is 78.5 centimeters squared. 78.5 centimeters squared. All right, find the area of the circle below. Round your answer to the nearest hundredths place. All right, so I'm going to find the area once again. So area is equal to pi r squared. Plug in the information I know. Well, I know that from the center to the outside edge is 8, which this is giving me the radius, so I do not have to do anything. So I have 3.14 times 8 times 8. 8 times 8 is 64, so I have 3.14 times 64. Let's go ahead and do it over here. 4 times 4 is 16. 4 times 1 is 4, plus 1 more is 5. 4 times 3 is 12. Done with the 4, placeholder. 6 times 4 is 24. 6 times 1 is 6, plus 2 more is 8. 6 times 3 is 18. 6 plus 0 is 6. 5 plus 4 is 9. 2 plus 8 is 10. 2 plus 8 is 10. 1 plus 1 is 2. I have 2 place values here, no place values here, so I need to move my decimal 2 times to give me an area of 200.96 inches squared. 200.96 inches squared. All right, number 5. The figure is created with a semicircle and a trapezoid. The semicircle has a diameter of 4. Find the total surface area of the figure. All right, so I got to open up and look at my STAR reference sheet. You can find this on Google Classroom. You can also find this on Google just by researching up STAR Grade 7 Mathematics reference material for Texas, and this will pop up. So I got to look over here at the area of a trapezoid, and I'm told that its area is equal to 1/2 base 1 plus base 2 times the height. So I'm going to go ahead and let's just write that down for our trapezoid. Area is equal to 1/2, open parentheses, B1 plus B2 times the height. Now, if you take a look at your reference sheet in the area section, you do not see the word circumference, but you have to know and understand that semicircle, that a semicircle is exactly half of a circle. So we're going to take the formula for the area of a circle and we're going to divide it by 2. And so I'm going to write semi over here, and it's going to be area is equal to pi r squared divided by 2. All right, so let's go ahead and do the trapezoid first. That one's a little bit easier because we don't have to deal with 3.14 just yet. And B1 and B2 are just my 2 bases. In a trapezoid, I have 2 different bases, one on top and one on bottom. And it does not matter which one you put first because you are using the associative property and you're just adding the 2 numbers together. But the height of the trapezoid is this number right here. It shows you how tall the trapezoid is going to be, and that is 4. All right, so I have 1/2 because we have to use the order of operations. So that means we have to do everything on the parentheses first. And 2 plus 10 is 12 times 4. All right, based on the commutative property, you can sit here and multiply in any order that you would like. So you could do half of 12 first and then or 12 times 4. I'm going to go ahead and do half of 12 first. So 1/2 times 12, which is 6, because 6 times 4 makes it a little bit easier, which is 24 meters squared. I'm not done because I want to know the area of the entire shaded regions, which means I've done the trapezoid first. Now we need to do the semicircle. All right, so I'm going to have area is equal to, and I'm going to write it down here, 3.14 times, well, here's the issue. I've got 4, and 4 is known as my diameter. Well, half of my diameter of 4 is 2. So I've got 3.14 times 2, all of that divided by 2. Well, 2 times 2 is 4, so we can go ahead and combine 3.14 times 4 divided by 2. Let's go ahead, and I'm going to kind of bring this all the way over here for a moment because I've run out of room. Do 3.14 times 4 over here. 4 times 4 is 16, carry the 1. 4 times 1 is 4, plus 1 more is 5. 4 times 3 is 12. 2 place value, so I need to move it 2 times. And I'm going to receive 12.56. And I'm not done. I still have to divide that by 2. So I'm going to have 2 on the outside, 12.56 on the inside. Because I typically mess up and lose some of my numbers, I'm going to bring my decimals straight up. 2 can go into 12 6 times with nothing left over. 2 can go into 5, 2 times 2, is 2 times with 1 left over, bring down the 6. 2 can go into 16 8 times with nothing left over, giving me a semicircle area of 6.28 meters squared. Now, I'm still not done. I still need to take these two numbers, and because I'm finding the area of the entire shaded region, I have to add these two numbers together. When you are adding your two numbers, you need to line up your decimals, which I have to add 0.00 because I have 6.28. So I have to have 24.00. Well, 0 times 8, or 0 plus 8 is 8. 0 plus 2 is 2. Bring down the decimal. 6 plus 4 is 10. And 2 plus 1 is 3, giving me a grand total area of 30.28 meters squared for the area of the entire shaded region. All right, number 6. All right, a model of rectangular stove top with 4 circular burners is shown. The side lengths of the stove top and the diameters of the burners are labeled. What is the measurement of the area in square inches of the stove top that does not include the area of the burners? So I just need to find the area of just the shaded region alone. Okay, so my stove top looks like it's in the shape of a rectangle. Well, we can use our handy dandy reference sheet and know that the area of a rectangle is base times the height. So let's go ahead and do that one first. My base of my rectangle is 24. The height of my rectangle is 22. So 24 times 22. Area is equal to, let's come over here, 24, 22. 2 times 4 is 8. 2 times 2 is 4. Done with the 2, placeholder. 2 times 4 is 8. 2 times 2 is 4. Add these numbers up. 8 plus 0 is 8. 8 plus 4 is 12. 4 plus 1 is 5. And I do not have any decimals. So my grand area of everything, including the burners, is 528 inches squared. Now I need to find the area of each of my burners. Well, I noticed that every single burner is the exact same. Same diameter, same shape, so they're all equivalent. So I'm going to find the area of one burner and then just multiply it by 4. So I've got the circle, and to find the area of a circle is pi r squared. Well, the diameter is 6, which means my radius is half of that, so the radius half of 6 is 3. So I'm going to have area is equal to 3.14, times 3 times 3. Area is equal to 3.14. Well, 3 times 3 is 9. Let's go ahead and come down here real quick. So 3.14 times 9. 9 times 4 is 36. Carry the 3. 9 times 1 is 9 plus 3 is 12. 9, 10, 11, 12. Yep. 9 times 3 is 27 plus 1 more is 28. I have 2 place values, so I need to move my decimal 2 times to give me an area of 28.26. Now, this is just for the area of one burner. I have 4 burners total, So I need to multiply this by 4 to find me the area of all 4 of my burners. All right, so 6 times 4 is 24. 4 times 2 is 8, plus 2 more is 10. 4 times 8 is 32. Oh, plus 1 more is 33. Whoops, I forgot that. 4 times 2 is 8, plus 3 more is 11. I have 2 place values, which means I'm going to move my decimal 2 times to give me an area of 113.04 inches squared. All right, so now that I have the area of the rectangle plus the area of my burners, what I need to do now with my 2 areas is the opposite of what I did for number 5, because I want just the shaded region alone, which means I want to take away the area of the burners. So I'm going to subtract. Well, I'm going to have to line up my decimals once again. And when I do that, I realize that I've got to add some zeros to my top number because you have to line them up. Now we notice that we've got a 0.04 over here, so I'm going to have to do some borrow and carry. Borrow from the 8 makes this 0 a 9 because I've got to borrow from it to make that 0 a 10. All right, 10 minus 4 is 6. 9 minus 0 is 9. Bring down the decimal place. 7 minus 3 is 4. 2 minus 1 is 1. 5 minus 1 is 4, giving me a grand total area of 414.96 inches squared. Giving us a grand total of 414.96 inches squared. All right. Here we go. 3-dimensional figures. A polyhedron is named by its base and its faces. So fill in the blanks. Pyramids have blank bases, that is a polygon, and lateral faces that are blank. Okay, so a pyramid has one base and lateral faces that are triangles. A prism has 2 bases, and the bases are blank, and the lateral faces are, hang on, the lateral faces are rectangles. I actually don't know what word goes in there. I know that the bases are congruent. Prism has 2 bases. The bases are... Oh, okay. If we're talking about it, we're talking... Okay, I see what you're saying. So your bases are congruent, yes, but for your bases, the shape of your bases, you can have a triangle or you can have a square or a rectangle. And then your lateral faces are rectangles. All right, I see what it's saying. All right, nets. Nets are 2-dimensional representations of a 3D solid. The net of a polyhedron is made up of polygons that are faces of the solid. To find the area of the net, find the area of each polygon in the net. The lateral surface area is the sum of all of the faces of the solid and not the bases. The total surface area is the sum of all of your faces, including the bases. So it gave us here 3 separate areas that are very useful for us. Area of a triangle is 1/2 BH. Area of a rectangle is base times the height, and area of a square is side squared or base times the height in that general sense. Number 8, what 3-dimensional shape can be formed by the net below? So if I take all 4 of these sides and I pull them up, well, I see one shape is the bottom of my base, which tells me this will be a pyramid, and it's in the form of a square. So this could be known as a square pyramid, or I like to sometimes call it a rectangular pyramid. Because you know a square can be a rectangle, but a rectangle cannot be a square. But both of those would be perfectly fine. All right, so I've got lateral area and total surface area. So let's go ahead and find the lateral surface area, which means the lateral surface area is the area of everything without the base. And my sides are in the form of a triangle, which means it is 1/2 base times the height. If you take notice about your shape, the base of your triangle is 4.5 and the height of one of your triangles is 5. And we are to presume that each of our triangles are the exact same base and height. So I'm going to have area is equal to 1/2 times 4.5 times 5. So I'm going to come over here, 4.5 times 5. 5 times 5 is 25. Carry the 2. 5 times 4 is 20, plus 2 more is 22. I have a 1 place value, so I'm going to move my decimal 1 time. I have an area of 1/2 times 22.5. Now I need to take 22.5 and I need to divide it by 2. So I'm going to go up here, 22.5 divided by 2. 2 can go into 2 1 time, nothing left over. 2 can go into 2 1 time, nothing left over. Bring my decimal up. 2 can go into 5 2 times with 1 left over. Add a 0, bring it down. 2 can go into 10 5 times with nothing left over. Because our goal in division is to get to the very bottom without any repetition. Sometimes it happens though. All right, so the area of one triangle is 11.25. But for lateral surface area, it is the area of all 4 of my triangles. So I need to take 11.25 and multiply it by 4 because there are 4 of them. 4 times 5 is 20. Carry the 2. 4 times 2 is 8 plus 2 more is 10. 4 times 1 is 4 plus 1 more is 5. 4 times 1 is 4. I have 2 place values, so I'm going to move my decimal 2 times, giving me a lateral surface area of 45 centimeters squared. Total surface area is the lateral surface area plus the area of the base. Well, my base is in the form of a square, so it is base times the height, or we know that is side squared. And so the area is going to be 4.5 times 4.5. 5 times 5 is 25. 5 times 4 is 20, plus 2 more is 22. Done with the 5 placeholder. 4 times 5 is 20. Carry the 2. 4 times 4 is 16, plus 2 more is 18. 5 and 0 is 5. 2 and 0 is 2. 8 and 2 is 10. 1 and 1 is 2. I have a 1 place value here, 1 place value here. I have 2 in total, so I'm going to move my decimal 2 times to give me an area of 20.25. Now, I am not finished with this because total surface area is the area of the base plus the lateral surface area. So I'm going to add 45 to this, bring down the decimal of 0.25. 0 and 5 is 5. 4 and 2 is 6 to give me a grand total surface area of 65.25 centimeters squared. 65.25 centimeters squared. All right, number 9. The net of a cube is shown below. When folded into a cube figure, we have the side lengths of 2 centimeters. Well, one thing you need to know about a cube is that all of our shapes are in the form of a square, and we know the property of a square that every single side is going to be 2 meters. No matter where it's going to be 2 meters. So I'm going to go ahead and fill in 2 meters, kind of just a little bit of all over here so that way I know. Lateral surface area and total surface area. When we're looking at a cube or when we're looking at a rectangular prism, it's kind of hard to figure out which one are the bases, and you can't really go wrong too far with that, especially when I'm looking at a cube. I'm going to assume that these 2 little wings here are my bases. So the lateral surface area, I'm going to find the area of one of my squares, which is base times the height. My dimensions of my square are 2 times 2, which the area of one square is 4. For lateral surface area, I have 4 squares that are lateral surface areas. So 4 times 4 is 16. So my lateral surface area is going to be 16 meters squared. And then I've got to find the total surface area, which is adding the lateral to the area of my bases. So I can either do 2 times 2, 4, and do that times 2, which is 8. Or since they are all the same, and I see that there are 6 bases, so 6 squares, I know that the area of 1 is 4, and I can just do 4 times 6, which gets me 24, to give me a total area of 24 meters squared. All right, number 10. What three-dimensional shape can be shown by the net below? We'll take a look. I have all triangles. I have a one little one and then three big ones. And I'm going to presume that the little one is known as my base, which is going to give me the shape triangular pyramid. Triangular pyramid. All right, so lateral surface area is the area of all of my sides. Well, in this triangular pyramid, it's going to be all of my bigger triangles, and then the base is going to be my little one. So my bigger triangles have a height of 10, and it looks like this is an equilateral triangle. So that means every single side is going to be the same distance. So if this is 6, everything is going to be 6 right here on this little one. So my dimensions on the bigger triangle are 6 and 10. All right, finding the area of a triangle is 1/2 base times the height. So I'm going to have area is equal to 1/2 times 6 times 10. Remember, in my 10s trick, you can do the two whole numbers first. So 6 times 1 is 6. And I see that I have 1 0 between the two numbers, which is going to give me 60. Well, 60 and cutting it in half, or 60 divided by 2, is going to give me 30. Now, this is the area of just one of my 3 triangles. I need to multiply that by 3 to give me the lateral surface area. 3 times 0 is 3. 3 times 3 is 9 to give me a lateral surface area of 90 inches squared. Finding my total surface area, I now need to find the area of my base, which is also in the form of a triangle. So 1/2 base times the height. The base of my little triangle is 6. And if you notice on your paper, it might be easier to see the height of this little triangle. I kind of like colored it in. It's pointing an arrow to me, and it's giving it to me as 5.2. So I have area is equal to 1/2 times the base of 6 times the height of 5.2. All right, come over here. 5.2 times 6. 6 times 2 is 12. Carry the 1. 6 times 5 is 30, plus 1 more is 31. I have 1 place value, so I'm going to move my decimal 1 time. Area is equal to 1/2 times 31.2. Divide this by 2, so I'm going to have 2 on the outside, 31.2 on the inside. Bring the decimal straight up. 2 can go into 3 1 time with 1 left over. 2 can go into 11 5 times with 1 left over. Bring down the 2. 2 can go into 12 6 times with nothing left over. So the area of my base is 15.6. Now, to find the total surface area, it is the lateral added onto the base. So I'm going to have 15.6 plus 90.0. Bring down the decimal. 6 plus 0 is 6. 5 plus 0 is 5. 9 plus 1 is 10. So I'm going to have a grand area total of 105.6 inches squared. 105.6 inches squared. All right, solving for volume. All right, so the volume of a prism is found by multiplying the area of its base times the height of the prism. The height of the prism is known as the distance between its bases. So V is equal to capital B times H, where capital B is the area of the base and H is the height of the prism. The volume of a pyramid is found by multiplying the area of the base times the height of the pyramid, then dividing by 3. So it's the same thing as the prism, but at the end with the pyramid, you just got to divide it by 3. So we divide by 3 because we found that when we have a prism and a pyramid with congruent bases. Now remember, the word congruent means equal bases and heights. The volume of the pyramid is 1/3 that of the prism. All right, so let's fill in the blanks here. If a prism and pyramid have the same base and height, then the volume of the prism is 3 times the volume of the pyramid. If we know the volume of the prism, to get to the volume of the pyramid, you divide by 3 or multiply by 1/3. So taking a look right here at number 12, the triangular prism and the triangular pyramid are shown have congruent bases and congruent heights, which means my bases are equal and my heights are equal between the two. So if the volume of my prism is 45, so the volume of this is 45, what is the volume of my pyramid? Well, if I'm told that the prism is 3 times the volume of the pyramid, so if this is 3 times as large as the pyramid, what I need to do is take 45 and divide it by 3. So 3 is on the outside, 45 is on the inside. 3 goes into 4 one time with 1 left over. Bring down the 5. 3 goes into 15 5 times with nothing left over, meaning the volume of the pyramid is 15 inches cubed. Almost remembering when we saw the video of the water and where the guy or person had poured the water into the pyramid, and then they were able to dump the pyramid into the prism 3 equal times. So we could find the volume of the prism being 45. Well, I just want to know what's the volume of one of those, which means just take this and divide it by 3, which gets me 15. All right, number 13, name the three-dimensional figure and explain your reasoning. Well, looks like I have all squares and rectangles, so the name of my shape is known as a rectangular prism. With a rectangular prism, it's kind of hard to identify which two are going to be your bases. So in reality, it really does not matter which two are the bases, only for the rectangular prism. So I'm going to go ahead and just choose my 2 smaller sides to be my bases, because then that's going to help me with my formula. Now the formula of the volume of a prism is capital B times H. Remember, where capital B stands for the area of the base. Well, the area of my base, I have to look at the shape, is a rectangle. And to find the area of a rectangle is base times the height. So I have a 1.5 times 2 times the height, which is known as the distance between the two bases, which is 3. And then remember, step 3 is to solve. Now, if you notice, all you're doing is multiplying all 3 of the numbers together, which means it really does not matter which one is the base as long as it is a rectangular prism. All right, so let's go ahead and do 1.5 times 2, because that's what I have inside of my parentheses. 2 times 5 is 10. Carry the 1. 2 times 1 is 2, plus 1 more is 3. I have a 1 place value, so I'm going to move my decimal 1 time. So I have 3 times 3, which gives me a volume of 9 centimeters cubed. All right, looking at number 14. So name the three-dimensional figure and explain your reasoning. Okay, so here's where we need to understand. So a prism has 2 bases. A pyramid has 1 base. Okay, so I want to start seeing what shapes. So I see 2 different shapes going on. I see a triangle and I see a rectangle. How many triangles do you see? Well, I see 1 triangle here and then I see 1 triangle here. So I've got 2 triangles going on. Rectangles, I see my long side rectangle here. I see the bottom rectangle, and then I see the up and down rectangle. So I see 3 rectangles. Well, knowing my key, prisms have 2, pyramids have 1. Which shape do you only see 2 of? Well, we only see 2 triangles. So the base is a triangle, which tells me this is a prism, which gets me the last part of my name. So I start with my base, T-R-I, I totally already misspelled triangle. Triangular prism. In the name of your shape, it gives you the base, triangular prism. All right, so to find the volume, it's still a prism. V is equal to capital B times H. Now, to find the volume of our base, we have to find the area of my triangle, which we already know is 1/2 base times the height. The base of my triangle is 4. The height of my triangle is 3. So I have 1/2 times 4 times 3. So I'm going to go ahead and plug that in here. 1/2, 4, 3. But I still have the height of my prism, which is this. It's the distance between my two bases, which is 6. We do not need the 5 inches right now in 7th grade. All right, we got to use the order of operations, so I'm going to use PEMDAS. 4 times 3 is 12. Bring down the 1/2 and the 6. Half of 12 is 6, which gives me a final grand total of 6 times 6, which is 36 inches cubed. Why is it cubed? Because it is volume. We are taking 3 numbers or 3 sides and we are multiplying them together. All right, almost done. Number 15. Name the 3-dimensional figure. Well, if I go based off of my key that I wrote over here, where prisms have 2 bases and pyramids have 1 base, take a look. I look like I have a 1 bottom and a very tip-top corner, so I have 1 base. It's in the form of a square, so this also tells me it is a pyramid, and it can be known as 2 things: square pyramid, or sometimes I will call it a rectangular pyramid. Now, to find the volume of a pyramid, volume is equal to 1/3 capital BH. All right, so I've got to start plugging in my information. So I got to keep the 1/3 area of the base. Well, the base is a square, and to find the area of it is just base times the height. So 10 times 10 times the height of my pyramid. So the height of your pyramid is from the base straight up to the tip top, which is 12. All right, so V is equal to 1/3. Well, 10 times 10 is 100 times 12. I know that I cannot do 100 times 3 because that's not going to give me a nice easy number yet. So I must do 12 times 100. Here's where my tens trick comes in handy. 12 times 1 is 12, and I see 2 zeros between the 2 numbers, and I've got 1200 times 1/3. So I'm going to take 3 and divide it by 1200. 3 can go into 1 0 times. 3 goes into 12 4 times with nothing left over. I am not done because I must finish out everything underneath the radical sign. 3 goes into 0 0 times. 3 goes into 0 0 times. And the volume of this pyramid is 400 centimeters cubed. Last but not least, number 16. The volume of a triangular pyramid is 42 yards cubed. The height of your pyramid is 7. What is the area of the base? Okay, so it sounds like I need to start writing out my formula. So V equals 1/3 capital BH. Now I need to plug in the information that I'm given. Well, I'm given that the volume of my pyramid is 42. So I can go ahead and plug 42 in for V. I'm also told the height of my pyramid is 7. So I have equals 1/3 capital B times 7. I want to know the area of the base. So I want to know, what does capital B stand for? So I'm going to start using my knowledge from solving 2-step equations. And I'm going to do the first step of dividing by 7, because currently I'm multiplying 7 to everything. So I'm going to divide by 7 on both sides. Well, 42 divided by 7 is 6. So I have 6 is equal to 1/3 capital B. Well, I'm technically dividing 3 to everything. So when I solve this, it's this times this divided by this. So if I'm dividing by 3, I'm going to multiply by the reciprocal, and that's going to be times 3 on both sides, which 3 times 1/3 goes away, and I'm left with capital B is equal to 6 times 3 is 18. So the area of the base is 18 yards squared. If you guys have any questions, please come and find us and let us know.